Hello and welcome back to another episode of Math with So. Today we're going to be finding the coordinate value for the centroid on a graph. Now, spoiler alert, this particular video I'm going to be doing it the easy way, which will not always work. Part 2 of this video is going to be doing it the correct way, which is sometimes required algebraically. Okay, so the first method that we are going to use is by just graphing it. In order to find the centroid, what you need to do is you need to find the middle point on any of the given sides first. Find the easiest one to do that for, which I'm going to pick this bottom part. If we go from y to z, the middle point would be at -3. Because we're at -6 and 0, and the middle is -3. And then from there, you are going to graph it, and you're going to go from here to the opposite angle. Okay, so if we go from there to the opposite angle, like so, your centroid is going to lie somewhere on that line. Okay, so that's a nice important feature that you could use to find the centroid. Now it is hopefully going to be at one of these two dots. All right, now with that in mind, if you want to find it out correctly, you should also go in the middle of one of the other lines. So I'm going to pick from z to x. What is the midpoint there? Well, the midpoint there, it's going up by 3. The midpoint here is actually at 1.5. All right? And if we go and do the same exact thing here, we are going to get a value that ends up going through here. So we get the value at -2, comma 1. That would be the centroid. Okay? The intersection of it. Now you can prove that it is kind of, again, that this is the cheap method, by counting. The centroid is going to be falling in a ratio of like 1 part to 2 parts. So see how here we jump by 1 slope version, and here we jump by 1, 2. So it is working. And what about here? We jump by like 2 parts, like see how it's going down 1 over 2? Here we went down by 2 and over by 1 in a way. So it is still working in that ratio. Again, this is the cheat way. I'm going to show you the official way on part 2. So next one. Let's find the midpoint between these two. We are going from 5 to 2. If we're going from 5 to 2, that is a span of 7. And if we take 7 and we divide by 2, 7 divided by 2 is 3.5. So we would have to go 1, 2, 3.5. Does that look visually like the middle? Yeah. And then we go from there up through to the other corner. Okay? Keeping that in mind, knowing that it is going to divide it into a 1 part to 2 part ratio, and the longer part will be from here, the corner, to the centroid, I am betting that the centroid is going to be in this location. Okay? Let's see if we can prove it. Let's try and find the midpoint of the side E to F. So here we're going down by 1, 2, 3, and over by 1. And then we went down by 1, 2, 3, and over by 1 again. So that must mean that this is the midpoint because we kind of like did the slope again. We went down by 3, over by 1, down by 3, over by 1. That must mean that that is the midpoint. And if you think about it, we went down by 6 and over by 2. Half of both of those is just down 3 over 1. Connect the dots. Let's see what we're looking at. We got the connected dots right here. There is the centroid, which is at -1, comma 2. Beautiful. Next one. Let's try it one more time. We got 1, 2, 3 to the left and 1, 2, 3 to the right. That must mean that that is the midpoint of the side R to P. We're going to go straight to the opposite corner, which is definitely right there. And then we could divide this in a ratio of 2 parts to 1 part, where we have gone 1, 2, 3, 4, 5, 6. Well, what is 6 divided by 3? 6 divided by 3 is 2. So if we do that, we would have 2 here and 1, 2, 3, 4 there. See how this is 1 and that is twice as big type of deal? Now, if you don't see that, that's fine. you could also find the midpoint of either one of these two sides, which is going to be difficult because look, it's slanted, and I'm betting the midpoint is somewhere like here, right? Does that visually look like the midpoint or the what is the right word? Segment bisector of that triangle. So that looks visually about like the middle, and if we go straight from here to the opposite corner, notice that we still get through that point that I was saying. Okay, so you can cheat the system. This is a video about how you can kind of cheat to get close, but it's not always a guarantee. So what is this point? This point is at -3, 4. There we go. All right. Be careful not to put the midpoint here. Like a lot of people are tempted to kind of draw that line. That is not correct. We don't want to necessarily go straight perpendicular. We are looking to go to the middle and then go straight to the opposite angle. Okay, so to me, this visually looks like the middle of that side. I just picked that side because it looked like it was going through clearly. I'm pretty sure that this one would be around here at the 1 or the 2 mark. So that would look visually, actually that looks a little bit too far to the right. Maybe it's over here. Does that look a little too far to the left? Well, maybe it's somewhere in between them. Okay, so again, this is all about how to do it by kind of eyeballing in a way. So let's confirm the eyeball. All right, let's see for this first one from L to M. We went to the right by 1 and down by 1, 2, 3. If this is the halfway point, I need to go to the right by 1 and down by 1, 2, 3 again, and I do. So that proves that this is, in fact, the middle of that side. Whoop, I missed. When you're doing this, notice how I am using a ruler. Okay, if you use a ruler, you are more likely to be successful with this method. If you do not, and your hand skews a little bit, you're not going to be able to find it as easily. So right here, it looks like it goes through this point. It also looks like it goes through that point. Which point is going to be the centroid? Remember that the part that is longer will be from the corner to the centroid. So this is going to be the point that I would expect it to be at. Let's see if it actually does. This eyeballed middle, will it go through that when I go to the opposite corner? Yes. Okay, so that means that the centroid is going to be at 1, -2. Okay, now that is the cheat method. The cheat method is fantastic when you're doing problems that are already graphed. It is also fantastic when your centroid is actually on a coordinate point. The issue that you're going to run into is what happens when the centroid is not on a coordinate point, okay? And that could happen anywhere. Like any one of these problems, the centroid could have been a little bit off. And if that happens, you are going to need a different method, and I would recommend part 2 for that. You are also going to need a different method if it's not graphed for you, okay? So recommend part 2 for the video when you want to know how to do it, maybe the correct way. See you then. Bye.